Somewhere right now, a website needs a hero image in under 100 milliseconds. A hospital must keep a medical scan for years. A startup is drowning in user uploaded videos. And a compliance officer needs a file nobody has opened since 2019. But that file still has to exist intact when the auditors call. Treat every one of those files the same way, and you either waste a fortune or put something critical at risk. Guess wrong about which files matter tomorrow, and the bill or the outage arrives later. This is the quiet problem modern applications hit the moment data stops fitting on a single disk. How do you store everything, from a hot website asset to a decade-long archive, without treating every byte the same? Amazon S3 was built as one answer to that dilemma. Not a hard drive in the sky, a programmable bargain between speed, cost, durability, and control. Before you can make that bargain, you have to know what is actually being stored. S3 is object storage. It does not pretend to be a traditional hard drive with nested folders. Under the hood, the architecture is flat, deliberately non-hierarchical, so the service can scale virtually without limit. The two building blocks are simple. A bucket is a logical container for your objects. An object is the thing itself, four parts glued together. The key is the name, something like photos/vacation.jpg. The value is the raw bytes. Metadata is a set of name-value pairs describing the object, for example, content.type image/jpeg, and size. An object can be empty or stretch all the way to 5 terabytes. That vacation photo is not a file sitting in a folder tree. It is an addressable object living inside a bucket, ready to be fetched from anywhere on the internet. If the system is flat, how does it hold virtually anything without collapsing into chaos? Two rules keep the map readable. Bucket names live in a global namespace. They must be unique across every AWS account on the planet, more like a domain name than a local folder label. And every bucket is region specific. You create it in a place like us-east-1, and the data stays in that region unless you explicitly move it. Together, those choices turn a simple container into infrastructure that can grow without a hard ceiling. Capacity is no longer the bottleneck. But scale alone does not pay the bill. A hot website image and a 7-year compliance archive cannot cost the same and still make economic sense. That tension is where S3 storage classes enter the story. Think of storage classes as rival strategies in one system. Pay more to touch data instantly, or pay far less and wait. S3 standard is the everyday workhorse. Frequent access, data spread across at least 3 availability zones, about 2.3 cents per gigabyte for the first 50 terabytes. Static websites, cloud apps, anything you hit all the time. Standard infrequent access drops the price to about 1.25 cents, still across 3 zones. For long-lived data you touch less than once a month, backups, disaster recovery, it carries a 30-day minimum storage period. One zone infrequent access goes cheaper still, around 1 cent, but keeps data in a single availability zone. Fine for reproducible secondary copies, riskier if that zone fails. Then the cold side of the spectrum. Glacier Instant Retrieval is built for rare, often quarterly access. Medical records, compliance files, with millisecond retrieval, about zero point 0.4 cents a gigabyte, and a 90-day minimum. Glacier Flexible Retrieval is roughly 10% cheaper again, for yearly archives where minutes to 12 hours of wait is acceptable. And Glacier Deep Archive is the deep freeze, about a tenth of a cent per gigabyte. 12 plus hours to retrieve, a 180-day minimum, meant for 7 to 10 year retention. Lowest cost, longest patience required. S3 does not erase the trade-off between instant access and low cost. It makes that trade-off programmable. Here's the bargain made concrete. Imagine a photo app that stores 10 terabytes. 1 terabyte is the hero images users open every day. 4 terabytes are last season's albums, opened maybe once a month. 5 terabytes are legal holds and old originals nobody has touched in a year. If everything sits in S3 standard, you pay about 2.3 cents per gigabyte month on the first 50 terabytes. 10 terabytes is roughly $230 a month, just for keeping the bytes warm and ready in at least 3 availability zones. Move the 4 terabytes of infrequent albums to standard IA, and the rate drops to about 1.25 cents per gigabyte. But you accept a 30-day minimum storage duration and a retrieval fee when someone actually opens an old album. Park the 5 cold terabytes in Glacier Deep Archive near a tenth of a cent per gigabyte, and the bill collapses. If you can wait 12 hours or more when a court request arrives, and you keep that data at least 180 days. One zone IA is cheaper still than multi-zone infrequent access, but it lives in a single availability zone. Less durable. Fine for regenerable thumbnails. Wrong for the only copy of a medical scan. Glacier Instant Retrieval sits in the middle of the cold world. Rare access, millisecond reads, about 4/10 of a cent, 90-day minimum. Flexible retrieval trades minutes to hours of wait for a still lower price. The latter is not a menu of equals. It is a set of contracts between how often you touch a byte, how fast you need it, how many buildings must hold a copy, and what you are willing to pay every 30 days. Knowing the latter is one thing, climbing it by hand every month is another. When access patterns are unpredictable, intelligent dash tiering watches how often an object is touched and automatically moves it between tiers. You pay a small monitoring fee per 1,000 objects, and you avoid retrieval fees while the system hunts for savings you would miss by hand. Lifecycle rules go further. You write the policy once. S3 enforces it forever. A classic pattern from real operations: move objects to standard infrequent access after 30 days, then to Glacier Deep Archive after 365 days, then expire. Delete them after 7 years. That single rule turns a forgotten backup into a cost curve instead of a permanent line item. Cheaper storage, though, is useless if the wrong person can reach it, or if the data you just wrote is somehow stale. Before trust and encryption, there is the ordinary work of putting data in and keeping it under control. The path is almost disarmingly simple. Create a bucket in the console. Upload objects through the web UI, through code, or with a single CLI line. AWS S3CP, your local file, then S3 / your bucket name /. Permissions come next. Private is the default mode, and that default matters. You decide who can read or write, object by object, or for the whole bucket. Then lifecycle, which we just met, and monitoring. Turn on access logging so you can see who requested what when. You can drive all of this from 3 doors: the AWS Management Console in a browser, the CLI, AWS S3LS lists your buckets, or programming scripts, Python with the Boto 3 library being a common choice. Storage only becomes infrastructure when humans and machines can both operate it cleanly. Once a bucket exists, 3 doors lead into the same flat space. The AWS Management Console is the visual door. Click, drag, inspect. It is perfect for learning and for one-off fixes, terrible as the only tool for a million objects. The command line is the craftsman's door. A single copy command pushes a local file into a bucket. AWS S3CP, then the local path, then S3 // the bucket name, and a trailing slash. List what lives there with AWS S3LS. Scripts wrap those verbs so overnight jobs can archive logs without a human at the keyboard. The third door is code. In Python, the Boto 3 library speaks S3 as a first-class citizen. Create buckets, put objects, generate URLs, wire lifecycle rules from the same place your application already runs. Console for site, CLI for ops, SDK for product. Permissions sit across all 3 doors. New buckets start private. That default is not a suggestion. It is the first wall against an accidental public leak. From there, you decide who may list, who may write, and whether any anonymous reader on the internet should ever see a single key. Monitoring and access logging close the loop, so when something odd happens at 3 in the morning, the trail still exists. Here is the fear every distributed system has to answer. Did I just read yesterday's file? Since late 2020, S3 gives strong read after write consistency for all applications. Write a new object or overwrite an existing one, and the next read immediately returns the latest version. No more hoping eventual consistency catches up before your users notice. Versioning attacks a different nightmare: the accidental delete, the bad overwrite. Keep multiple variants of an object in the same bucket. Delete something by mistake, and S3 does not vaporize the bytes. It inserts a delete marker and retains the previous version, so you can restore it. Overwrite good data with bad, and you can roll back to an earlier version. Consistency says the present is trustworthy. Versioning says the past is recoverable. Together, they turn a dumb shelf into something you can build a business on, if you can also lock the door. Locking the door in S3 is not one switch, it is a stack. Bucket policies are JSON rules attached directly to the bucket. IAM policies grant users, groups, and roles permission to act on specific buckets and objects. Access control lists still exist, but they are legacy. AWS recommends disabling them and preferring bucket or IAM policies. Block public access sits above the rest as a centralized guardrail against accidental exposure, and it is on by default for new buckets. Encryption protects the bytes at rest. Server-side encryption with S3 managed keys is the default path. KMS adds an audit trail and key rotation. Customer-provided keys put you fully in charge. Or encrypt on the client before the upload ever leaves your machine. None of this is optional theater. A misconfigured public bucket is how private data becomes tomorrow's headline. The controls exist so that private by default can stay true as teams and applications multiply. Protection inside one region is not the same as surviving a regional disaster or handing a stranger a temporary key. Cross-region replication copies objects automatically to a bucket in another AWS region for disaster recovery or lower latency closer to users. Pre-signed URLs solve a different problem: temporary controlled access without opening the bucket to the world. Generate a time-limited link so someone can download a premium video or upload a file straight to S3, never routing the bytes through your app server. Object lock implements worm: write once, read many. For a fixed period or indefinitely, an object cannot be deleted or overwritten. Essential when legal holds demand proof that nothing changed. And S3 Select lets you pull only a slice of a huge CSV or JSON object with a CQL expression, so you transfer less data and pay less for the privilege. These are not checklist features. They are the moment storage stops being a passive shelf and becomes part of the application itself. Remember the 4 files from the opening. The website hero image lives in standard, served fast from a bucket that can also host an entire static site. HTML, CSS, JavaScript, with low latency. The startup's user videos and documents sit as application content behind controlled access. The hospital scan and the compliance archive slide down lifecycle rules into Glacier classes, cheap enough to keep for years, locked if the law requires it. Backups and analytics lakes use the same foundation, feeding services that query and learn from massive datasets. S3 did not abolish the tension between instant access and low cost. It made that tension programmable: objects in buckets, classes on a ladder, rules that move and expire, consistency you can trust, versions you can restore, encryption and policies that keep the private private, replication and locks when the stakes leave the building. What remains open is the question every growing system still faces. As data multiplies and access patterns keep changing, how intelligently can storage balance cost, speed, durability, security, and compliance without forcing people to predict a future nobody fully